Hi everyone, now let us learn the BFS with theory and the practical. So the BFS stands for breadth first search, right? So I will just create a simple note for you guys to be understanding. So I will take A, B, and here C, A. Okay, just a minute. It should be coming this. It should come in the same level, right? B, A, B, C. Oh, okay. C. Oh, it is coming not there. Okay. A, B, C, ABC, and I will here take ABCD and E, and here down I will take F. So I will just give the lines for here. A to B, let me make a little bit shorter. Okay, yeah, A to B, A to C. Okay, A to C connection, then B to D, and B to E, and E to F. This is the our what we can say. This is our nodes which are the BFS. So it's go by level. First it go this level. First A is one level, and B and C is the another level, and D and E is another level, and F is another level. So this also represents zero level, 1, 2, and 3. Okay. So how it is gone? So first it will traversal A. Okay, it first traversal. Just a minute. It's first traversal A. Then in the below we have B, right? As you can see, we have B. It traverses the next line. It will just traverse a B, and it's level by level. First, it complete the full level, and it will see the next thing C, and it will go for the next level, and it will check which node has next level. Like B has D and E, D and E, and in the next level we have only F. So we'll write this. So this is the output of our this thing in theoretical way. Theory, it is very easy to understand. In the practical, I will explain you in a very easy format where you can understand for a lifetime. So let us write in a function. No, before writing function, let us write this type of graph in the coding format. In the coding format, write graph with the flower brackets. Okay, and here you want to write in single quotes or double quotes the particular node name. In that particular node, what are the elements are there? In the A we have B and the C, right? And we have next B element. See, I will just show you. So I now turn here. A has B and C, and I want to write what does the B node has. So B node has D and E, D and E, right? D. Now I put comma, and we have next C. C doesn't have anything, so we'll put empty. And next node is our D. So in our D we doesn't have anything, so we'll keep it empty. So next we have E. In the E we have F. Okay, so in the E we have F, and in the F we want to just check it out all the nodes. Okay, in the F we doesn't have anything, so it is empty, so it is also empty. So now we have written the structure of the theory format into an programmatic way. So you want to we need to fall on need to solve it. As everybody know, the this particular BFS follows the queue stack. So to queue we can use import the dq or queue, but we'll use v is equal to empty with this this, and q is equal to this one. So now I will write a function called as dfs as a bfs means b sorry I mean bef means it is a function format, and bfs is a what I'm giving. So BFS with I'm passing the uh, variable means visited. V means visited. Q means Q. Okay, visited, and the I will provide the graph. G means graph. Okay, and N means node. So I will provide all this information, and here visited dot append, append, the append. So append means we will add the particular node which I am passing. So I'll get to know what is this n, how to pass it. Okay, then we will have a q dot append. So we'll pass n. Okay, I will just write a while loop, w h I l while q. So in here I will just save some variables, like I will just pop the thing like that node. No, I will just pop 0, the particular element which is stored in the first time, that will be popping out. So print s with the double quote, non double quotes. First you want to end is equal to with this. So what happened, this will display the particular popping element, like a, first it will display a. Okay, then it will end, it give the spaces. So what happened, s will pop up, and it means q dot pop below, pop the a. So, I will just explain you after writing the full code. Okay, and the next code will be writing the fall I, no n in uh, g of s. Okay, then we will write an if condition, if n not in, if n is not in visited, so then it should be having the same procedure, like q v dot append of n means neighbor. Here you can write neighbor. Okay, nib neighbor, and a q dot append. Okay, or else if you write n also, it is fine if you write, but it should be also n, but I will write nib because for your clear clarifications. Here I will just call that function BFS. Okay, v will be same, q g will be same, and n will be our input a, where it should be start from. And I will just run the code, and as you can see, I'm getting some output as a. So we have some error in this particular code. Let us check it out. So we am passing v and g and n, append n, okay, q, while q is a pop, and print neighbor of s. If n is not in the v, it should be we dot append nib. Okay, just a minute, let me make it n n n. Okay, yeah, just sorry, just a minute, I just told here it should be also a nib neighbor. Okay, let me run again and see. Now it is solved. What the mistake has done, I done the mistake, like here I have written nib neighbor, here I just write n. That was the problem. Now let me execute. So we got the output exactly a b c d e f. Now I'll explain the code. We are passing a. When passing a will be going to this one, and n will be appended to visited, and the q. The q will be first loading this one, s will be storing a. So the printing will be first a. After printing a, here neighbor means it will check the next node. So in a we have b and c. So the same vice versa, the repeat things will be happened until the queue is empty. The queue is empty. If the queue is true, means true, it will, the loop will be continue. If it is false, it will exit. That's all. Yeah, thank you. All the best.